Warm-up 84, by now you should be able to do these, yes. We've been doing this like almost for 2 weeks now. Let's see. F of -2 right here should have been equal to 1, yes. Good. And F of -2 here should have been 1/10. So far so good, yes. All right. For number 2, this negative is going to flip the function, and then we're going to go 2 steps to the right and 1 up. Okay, good. 3c, you should have gotten b squared over 25. And last but not least, number 4, 7 to the x over 49. We're good? Yes? All right. Agenda for today, warm-up number 84. We're still on rational functions. Home play, 8 problems, graphing. And just so that you know, today we're moving on. And we're still on rational functions, so I'm introducing 2 new types of rationals. You'll see that in a moment. So, being that today is Friday, no pop party today though, but I am giving you a heads up, it would be when? On Monday. So, make sure you do your home play over the weekend, because that's basically the pop party for Monday. Okay? So, home play from last night, 4 problems. That was me, free, from me to you. We good, yes? All right. But you did the practice pretty good, yeah? All right. Tonight's home play. There it is. 8 problems. Graphing. Once again, make sure you do the practice, because it's all graphing. And as I mentioned before, we're going to continue this semester. Keyword or key phrase, hashtag graphing. So get familiar with that. All right? We good? All right, here we go. Our objective for today, I can write, solving graph rational functions. I can write, solving graph rational functions. You don't need a Frere model. So like I said, today we're going to be looking at some different types of rationals. But I do want to revisit what we did this past week and also yesterday, that we reviewed all of the functions. So where have we been? We did a Frere model. Yes, we know what they are. We talked about the different steps. We went through our general form. We talked about asymptotes, that they were the vertical and horizontal. We did examples like this, like that, like that, like that. I had you write a equation given a graph. You did that, that, and that. From there, we moved on from there and introduced a new type of rational, which is the one on the screen. And then we went from there to here, from there to there, from there to there. And yesterday, we actually did some different types of functions to make sure we understood which one was which. So, writing utensils down, look up to the screen. So if I was to give you these functions, g of x, don't copy this, 3 over x plus 4 minus 5, or g of x equals 3 over x plus 4 squared minus 5. Are they rationals? Yes, because they are fractions. Bless you. But it's 2 different type of graphs. Tell your neighbor which graph is which. There's 2 types of graphs on the screen. Tell them which one is which. All right, so yesterday, like I said, we covered this, and we said that the denominator is what tells us which kind of graph do we have, right? So if you notice, this one doesn't have an exponent, this one does have an exponent. So let me ask Leo, what kind of graph is this one? J-Lo, yes, the J and the L. That is correct. Why? Because it's got the squared on the denominator. Which means the only other option for this one is like this and like this. Those are the only two types of rationals that we know. So far so good, yes? Because today we're moving on. I just want to make sure that we got this, yes? All right. Copy this one. Example number 4. And for today, don't worry about all the instructions. Today, I just want you to graph what we have in front of us. That's all I'm going to need for you tonight, to understand which graph we have. Okay. So the equation given, or function given, g of x equals 1 over x squared minus 36 plus 3. Look at the denominator and tell your neighbor what kind of graph do we have here. Talk it over to your neighbor. What kind of graph do we have? All right, Leo, pass someone. Pablo.
We have the one
Did we hear that? He said the J-Lo. Is that correct? Tell your neighbor why the J-Lo? Because it's got a square on the denominator. Let me go back to the previous one that we just saw. This one with a squared was J-Lo. This one does not have a square on the denominator. This new one for today, we still have a square on the denominator, which means we should end up with something like this. All right, so write your utensils down, look to the screen. So I'm going to start my coordinate plane. And of course, I need my HA and my VA. Here it goes. VA x equals, and you're just paying attention, you'll copy in a little bit, HAY equals. I'm going to give you the easy one first. The 3 is here. Yes? 1, 2, 3. The VA we need from here, but since it has a squared, we have to set this equal to 0 and solve. Because we need to leave x by itself. Right, Mario? So we add 36, x squared equals 36, square root, x equals plus minus 6. Yes? That means my VA is plus minus 6. Now we have a dilemma here. What is my VA? Positive 6 and? So watch. But Pablo said that our graph is a what? J-Lo. So that means I have a J over here and an L over here. Do you see it? The only thing, the VA split up to 2. However, what do we do with this empty space? We do this. Look up. That's the only difference on these. When the VA becomes 2 VAs, you need to fill in with an inverted, looks like a quartic type of graph. Copy that, please. All right. So far, so good, yes? That's all I'm going to ask you for some of the homework tonight, just to graph. I just want to make sure that you're understanding what kind of graph we're looking at. Okay, from 1 to 5 up to right there, how you feel with these. Yeah, 5, 4, 5, 4. Let's do another one, just to make sure we got it. Example 4Q, copy this. G of x equals 1 over x squared minus 64, and then at the end, minus 5. Graph that one. But before we graph it, look at it, look at the denominator. Tell your neighbor what kind of graph we should end up with. All right. Pablo, pass on one. Sebastian, so what kind of graph are we going to end up with? Yeah, J-Lo, yes, J-L, like that. Why? Because it's got the square on the denominator. Okay? All right, so let me get you some help. Here you go. There you go. All right, Sebastian, pass someone. Diego, what'd you get for your BA? 8. Hands if you got that. Close. Tell your neighbor what's missing. Plus, minus, because it's a negative 8. And a positive 8. Pass someone, Diego. What is our HA? Minus 5, negative 5, which is down here. All right, and Sebastian said we end up with a J-Lo, so we have J, L. So what do we do with this empty space down here? Our upside down curve, yes? Hands if you got that by yourself? Yeah? Now, for those of you that missed how we got, once again, our VA, make sure your denominator, you set it equal to 0. Add 64 to each side. X squared equals 64. To get rid of the square, we do a square root to both sides. X equals plus minus 8. That's how we get that. All right, 1 to 5, I'll come to party with these. 5, 5, 5, 5, okay. Let's do another one. Here we go. Copy this one, example 4, supercube. And the equation given, the function given is g of x equals 1 over x squared minus 5 plus 1. Okay, I'm going to give you the easy one. HA is 1. Yeah? Okay, 1. Horizontal asymptote. There it is. How about our VA? Let's see. Equal to 0 plus 5 plus 5. X squared equals to 5. Square root. X equals plus minus square root of 5. What's square root of 5? Oh, it's approximately. Okay, so how do you find the square root of 5? Tell your neighbor, please. So between what? That's the one that's in between the two perfect squares, right? It's in between what? 4 and 9. Right? 5 is in between 4 and 9. Okay, so what is square root of 4? 2. Square root of 9, 3. So this has to be between 2 and 3. So this is going to be plus minus 2 point something, approximately. Okay, so let's find out something. 5 minus 4, 1. 9 minus 4, 5. 1 divided by 5 does not fit in there. 2, 10, subtract 0, so this is 2.2. So that means we got negative 1, negative 2, negative 3, so 2.2 is about right there. 1, 2, 3, so 2.2 is about right there. And we said this was a what kind of graph? J, low, right here and right here. And of course, this. How are we doing from 1 to 5? How comfortable are you with these? Yes? Okay. Now look up just in passing. Look up. Now that we have our graph with a different color, do this. Put a negative between the equal sign and the fraction. What is that graph going to look like now that you have your green negative there? Tell your neighbor, please. Yeah, it's going to do this. It's going to invert all of the graphs. Do you guys see it? Yes? Yes, Mr. Q. All right. Are we doing good? All right. Look at this next one. Don't copy it. But notice, same process. Set it equal to 0, plus 30, square root of 30. You need to find the square root of 30, approximate, find your dA, and so on. Okay. All right. We good. Let's crank it up, yeah? Example 5. Copy this one. We are given, for example 5, g of x equals x squared plus 5x plus 6 over x plus 1. Okay, so before I start graphing this one, according to what we know, we look at the denominator. Tell your neighbor what kind of graph should we end up with. Talk to your neighbor. What kind of graph should we end up with according to the denominator? Yeah, this one. Like this and like this. Why? Because the denominator does not have a square. The previous ones, look at this one, the denominator has a square. That's why that's a J-low. Yes? All right, we got it to right there? All right, write your utensils down, look up to the screen. Here it goes. It's going to go pretty fast. Because tonight, all I need for you is to graph the graphs, and that's it. That's the only practice I want you to get used to tonight. Here it goes. VA, x equals to what? Let's see, Zachary. -1. That is correct, because if I was to set this equal to 0, -1. Are we there so far? All right, so pay attention You'll copy at the end. Here it goes. Watch. Okay. But if you notice that it's got no constant at the end, look what I'm going to do now. Since we have something on the numerator, now on the denominator, what is it that your brain wants to do? Very good. Long division. X squared plus 5x plus 6 divided by x plus 1. Pay attention. Here it goes. You'll copy at the end. What number times x gives me x squared? X. X times x, x squared. X times 1 is 1x. I'm going to subtract, which means distribute, this cancels. 5x minus 1x is 4x. Bring down the 6. Continue. What number times x gives me 4x? Positive 4. 4 times x is 4x. 4 times 1 is 4. Subtract. Distribute, this cancels, so we're left with 2. Now check this out. Usually, I would say that we need a HA here, but today, I don't know if you noticed that the numerator has a higher degree than the denominator. This is the very first time this happens. It's usually the same degree, 1 and 1, or the bottom, the denominator, has a higher degree, which is squared. But now it's the other way around. That's why this is a little bit different. This is what we call the SA. And we still need to find the Y. What does that mean, Mr. Q? SA means slant asymptote. So look, I got this. This is all I'm going to worry about today. And I'm going to write it here. X plus 4. So to right there, copy that, and then I'll finish off the rest so that you understand what we're doing. All right? So, look up to the screen, please. So we graphed the VA, and it's x equals to a number. That's why it's a straight line, which means this is also a straight line. But now it has a slope. Do you guys notice that? Because we have an x with a number. How do we graph that, Mr. Q? Well, we start with what? Positive 4. And then what's my slope? 1 up, 1 to the right. 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 Or 1 down, 1 to the left. 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 And this is my slant asymptote. Copy that. All right. Now check this out. According to what we said at the beginning, because the denominator does not have a square, we should end up with something looking like this. Yes? Look up. So we should have a vertical asymptote or a horizontal, but in this case we do have the vertical, we don't have the horizontal. What do we have now? A slant. But we still should have something similar to that. So look at this. Tell your neighbor where I'm going to graph my two curves. Where should I graph my two curves? Talk it over your neighbor. Where should they go? Do you guys see it? Some of you? Yeah. Right here. And right here. Does that make sense? The only thing that moved was the horizontal asymptote. It became a slant asymptote, but the graphs are still there. So here goes the process one more time. When you encounter these kind of functions that you have a quadratic on the numerator and just a regular 1 degree on the denominator, You should do your long division. That's going to be our slant asymptote, and of course our VA is here. You set it equal to 0, and that's how you get your x equal to. And then you just graph your graph. That's all I need from you tonight. Don't worry about the remainder and all of that we're going to do next week. But up to right there, that's where I want to make sure that you got. Okay? From 1 to 5, up and 4, I get to right there. 5, 4. Let's do another one to make sure we got this. Here we go. Example 5Q. It's g of x equals x squared plus 5x plus 4 over x minus 3. I'm going to give you a head start for this one, but let me get you started. Here it goes. There you go. Copy it. Now let's see where we're at. VA, x equals to what? Mal. 3, that is correct. 1, 2, 3. Hands, you got that? Okay. SA. What you get for our SA? Has someone, Mel? You know? Okay. Y equals what?
X plus 8.
X plus 8. Hands, have you got that? That is correct. Let me show the long divisions just to make sure we have the process correctly. So what number times x gives me x squared? That's x. X squared minus 3x. Subtract. Distribute. Cancels. This is 8x. Bring down the 4. And then positive 8 times x, that's 8x. Positive 8 times negative 3, that's negative 24. Subtract. Distribute. This cancels. That leaves us with 28 as remainder, but we don't worry about that. We just worry about this. That's how we get this. Therefore, positive 8. Slope is 1 up, 1 to the right. 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 1 down, 1 to the left. 1 down, 1 to the left. 1 down, 1 to the left. However, look at the denominator. What kind of graph should we end up with? Is it a J-Lo? No, it's the other kind, which means our graph should be here and here. Hands, have you got that? Okay. From 1 to 5, how comfortable are you with these? 5, 5, 5, okay. So, look at this one. Last one, example 5 mega cube. We are given, my goodness, g of x equals x squared minus 5x plus 6 over x plus 1. Give some time for that. Shouldn't take you long by now. Copy and. Alright, check your work on the screen. VA, x equals negative 1. Slant asymptote, y equals x minus 6. Hands, have you got that? Yes? We good? Did I make a mistake?
Yeah.
I did? Oh, remainder 12, no bad. Thank you. Yeah, I did that to see if you guys were paying attention. Remainder of 12. Yes. Oh, okay. All right, from 1 to 5, how comfortable are you with this? Okay, we'll stop right there, yeah? So once again, here goes the home plate. Check this out. Look at these. Do you know how to do number 1 by now? Yes. How about 2, 3, and 4? Yes. How about 4, 5, 6, and 7? Yes. And 8? Yes. So make sure you practice those. I just want to see the graphs and be ready on Monday, because Monday you have a pop party to attend to. Just giving you a heads up. Make sure you do your practice. Have a good one, guys. Enjoy your home play. Stop right there. Bye.